Okay, now we are considering 4 reservations case. So as I explained, the key part of this question is to calculate the number of possible outcomes included in this event. Okay, so basically you can imagine that there are 4 reservations and each reservation has 2 possible outcomes. So in total there are 16, 2 to the 4 number of outcomes, right? 16 outcomes, and if possible, you can just write down all 16 outcomes, and then you can count how many of them satisfy this event. Okay, first part is clear. If you imagine a single outcome where 2 reservations are canceled and the other 2 are not, you can calculate the probability this way. So success, cancellation, happens twice, and failure happens twice. So as a result, probability is 0.81%. Okay, this is nothing new and pretty much straightforward. Okay, but as I said, the problem is it is only one outcome. For one outcome, when you know who cancels and who doesn't. But we have to think about different combinations of the cancellations. Here I wrote down all possible outcomes. As before, 0 means not canceled and 1 means canceled, right? So A is canceled and B is canceled, C is canceled, and here A and B canceled. You can see here, and the last one is when all reservations are canceled, and right. So we are interested in the cases, the outcomes where only 2 reservations are canceled. And then you can think about 6 combinations. A and B, A and B, A and C, A and D, B and C, B and D, and C and D. So these are all possible combinations of 2 pairs, or pairs of 2 reservations canceled. Okay? So then the answer is 4.86%. So you have to multiply the number of combinations, 6, to this probability. So this, an outcome of this probability, there are 6 of such outcomes, right? And each of the outcome has this much probability. So the answer is D, right? 4.86% is the correct answer. And now then, okay, so when I write down the all possible outcomes, it is convincing, and it is clear. You can count how many satisfy the event. But the problem is, what you can find here is the answer is 6. But where did it come from? 6 is maybe you usually think it as 2 times 3, but there is only the number we only have is 4, 2, 10%. You never have 3. So where is that number coming from? That is very tricky. We are going to study that formula. We are going to generalize the counting rule. It turns out to be very tricky and complicated and kind of counterintuitive. I don't know. Still, I'm not confident to explain the intuition in 10 minutes. So I will just ask you to memorize that. It is just take it as a formula. Maybe this is the only formula that I ask you to memorize without fully understanding that. So to generalize the formula, we first need to understand this notation. N factorial. Exclamation mark in mathematics is called factorial. That is multiplication of consecutive integers, like natural numbers, from n down to 1, right? Multiply all positive integers from 1 to a certain number. That is called factorial, right? It is intuitive, but it is not the end. We are going to use this notation to define the number of combinations. So we define the number of possible combinations when you choose y number of units out of n possible candidates. Then we denote it as n chooses y. Like this is the notation, right? So again, like back to our example, what we are doing is we have 4 reservations, and what we are doing is we know 2 of them is canceled. 2 of them are canceled. So we need to think about, we are going to choose 2 out of these 4 candidates, reservations. So then you can choose like this, or like this, like that. So, and we are trying to count the number of possible combinations. That is denoted as this. So out of n reservations, we know y are canceled. How many possible combinations are there? That is mathematically this one. So this combination rule is an interesting rule and very useful. It can be applied to many other examples like lottery numbers. When you choose I don't exactly know the rule of Powerball or lottery. You choose like 6 numbers, like 5 numbers, 6 numbers out of 40 something numbers. Then how many possible combinations you get? I don't know. Like that is based on this rule, right? So the probability of winning prize by doing a lottery, like choosing numbers, correctly choosing the numbers, is based on this rule. Okay. And then mathematically, the result is like this. This is pretty complicated. I don't know where these numbers are from. So when you have n options and you choose y out of them, the possible combinations are n factorial divided by y factorial times n minus y factorial. So success factorial, failure factorial is in the denominator. Okay. So and then what you have here is, I'd say it this way. In the denominator, like if you cancel out this factorial, failure factorial with the numerator, then in the denominator you only have success factorial. Y is the number of success, so multiply y down to 1. So y number of numbers are multiplied in the numerator. In the denominator, excuse me. And in the numerator, actually the same number of multiplication is in the numerator. So 1, 2, 3, n minus y plus 1 is yth number. So you are multiplying the same number of numbers in the numerator and denominator, but the starting point is different. Here, you start from n, and denominator, you start from y. It's up to you, like how you memorize it and utilize it. But if you, I usually memorize it as our total number factorial divided by success factorial and failure factorial. Right? So, and one special case that is confusing is this one. When you choose nothing or everything, basically there is only one possible case. So n chooses 0 means there is no cancellation. There is only one combination because every reservation should not be canceled. That's the only possible scenario for this case. And similarly, when every reservation is canceled, that's the only possible scenario. You don't need to worry about who cancels and who not. There is only one scenario. So in these two special cases, when you consider these, you have to think about 0 factorial, but you don't need to worry about that. Just it is simply 1. Okay. So maybe the most famous example with combination rule is the playing card example, right? Suppose that you think about the case where you get 5 cards from 52 playing cards deck. How many combinations are there? This is the answer, right? If you play poker or a 5-card game, you get, say, think about the rule. You are going to multiply from 5 down to 1. So 5 numbers are multiplied in the denominator. And then you are going to multiply the same number of numbers in the numerator, but you start from 52. So multiply 1, 2, 3, 4, 5 numbers from 52 down to here. Okay? Another example. When you choose, you can, like when you order 2-topping pizza, and there are 10 topping options. How many possible combinations are there? That is like, so you have 10 possible options, you choose 2 toppings, then 10 chooses 2 is the number of possible combinations. And again, denominator, you multiply 2 numbers, 2 and 1. And the numerator also multiply 2 numbers, 10 and 9, right? From 10, right? So this is how you calculate the number of possible outcomes, possible combinations. Okay, so then you can apply this rule to any general case. Think about this. Now, if you think about 5 reservations and you are interested in the probability of 3 cancellations, how many combinations are there? You know, 3 reservations are canceled and 2 are not. And there were 5 reservations. How many combinations? So in our notation, you can write it as 5 chooses 3, right? Like this. 5 chooses 3 equals denominator, first 3 to 1, 3 numbers multiplied, and numerator, 3 numbers will be multiplied, but the first number is 5, 5, 4, 3. And then cancel out, then in the end you get 10. To check, you can write down all possible cases. I only wrote down where there are 3 ones and 2 zeros. So ABC, ABD, ABE, ACD, ACE, like that. There are 10 possible combinations like these. So I believe these exhaust all the possible combinations with 3 ones. So try to find what I did not list here. Maybe not. So again, the rule is this is the general mathematical rule to count the number of possible combinations when you choose a certain number out of certain total possible options. Okay, so then we get the final product. This is the general formula for binomial distribution. So again, scenario goes like this. You repeat a binary experiment n number of times, and each binary experiment is independent and has a probability of success with parameter p. And you are interested in the probability that y number of the experiments are success. How can we calculate that probability? The answer is, first, you count all the possible outcomes in that event, possible combinations of success out of n experiments, and multiply the probability of each outcome, right? When you know who cancels and who don't, then you can calculate its probability. That is the general formula. So remember these 2 parts. Okay, so in our example, n is the number of reservations. So 1 reservation is an experiment because each reservation turns into success or failure with probability p, and they are independent. And then the first part thinks about different combinations, who cancels and who don't. And the second part is about probability when you know who cancels. Okay? Then we will come back to the original question that I asked you. So, before this old derivation, I gave you this brain teaser, right? There are 10 reservations, and cancellation is 10%. Everything is independent. And then what is the probability that 2 reservations are canceled? The answer is E, which might be weird at the time, because all the numbers are simple, but suddenly the outcome, the result, is pretty complicated number. And now you understand why it is that complicated. Because, so think about this. There are 10 reservations and 2 are cancelled. Then you first need to think about combination of 2 out of 10 and use the combination rule, right? A combination rule like this. And then once you think about different scenarios and who cancels and who don't, then for each outcome, for each scenario, for each combination, you are going to multiply probability of cancellation twice and non-cancellation 8 times. Okay, so this is the probability of a single combination. And then you use the calculator or Excel, do the math, do the algebra, then you get this result. So actually it is much more difficult than you may have thought, right? So simply summarizing, the reason why this is more complicated than you think or what you missed when you imagine the answer is first typical common mistake or what you don't think in your mind is the failure. When I ask you to calculate the probability of 2 cancellations, you have to think about the other 8 reservations that are not canceled. So that part is usually ignored in your mind. So it looks simple, but actually it is not. And second, as you just saw, the number of different combinations is not simple. So counting the number of possible combinations is not a simple thing, or it's never like it's not one. You have to think about different combinations. That is usually not considered when you see this problem. So that's typical like blind spots when you think about binomial distribution. So I spent a lot of time to derive the formula, which is a general binomial distribution formula. And when you understand the principles, it is not that difficult, even though algebra is tedious, but idea is simple. So like in the next video, maybe the next one would be the last video this chapter. So I'm going to utilize this general distribution probability formula and talk about some basic properties and how to utilize this formula. Okay, thank you.